Yesterday we discussed about some libraries. What is the importance of them? What are those? NumPy. What it is? Use it for linear algebra because entire machine learning depends on this one only. Okay, but you need not to be a mathematician to implement that linear algebra. If you know when to use what kind of implementation, predefined functions are there. Okay, especially matrices related, vector algebra related, all operations are predefinedly available. And second thing is after NumPy, pandas. This is also one of the important thing. Especially this is used for data pre-processing, sir. But these two cannot train the models. For the training of the machine learning models, like you have another library. After pandas, for visualization purpose, what is that? Matplotlib. But you are a machine learning engineer, your purpose is to train model. Then why you should take care of visualizations? What is the need of them? During training only, please sit down, sir. During training only, how your model is learning, what is the learning curve you want to observe. Understand? So on such way, for machine learning engineer also, these visualizations will be helpful. Business intelligence people, how they use visualizations, that is different. How machine learning engineer will use visualizations, that is different. Understand the point? And next, what is another library? SciPy. Using this, what you can do? Especially complex data will be there, like images, audios, videos. You want to train our model, but input is images. Suppose face expression detection. Okay, or else object detection. Such kind of things you want to do. So before train our model, lot of pre-processing you need to do. If it is normal data, okay, simple techniques, okay, pandas, numpy you can do. But if the data is, if input data is image, audio, video, so regular programming techniques will not work out there. So at the time, the SciPy has predefined functions which are related with images, audios, videos. Image is what, sir? Finally, that is a triple dimensional matrix, RGB matrix. Each matrix is a row column pixel. Each pixel can be any value between 0 to 255. Finally, everything is number, but image structure is different, right? Image structure is different. Okay. And same time, audio means is a wave file, that is also a matrix. Video means collection of frames. Frame is a collection of images. Image again a three-dimensional matrix. How to pre-process your video? So for such kind of things, the SciPy will be used for you. And one more thing, yesterday we discussed scikit-learn. This is machine learning library. So basically three types of models will be there into the machine learning. Of course, approach is different. Supervised learning, unsupervised learning, reinforcement learning. In this way, different approaches will be there in the machine learning. But models, I am talking about models. Here, who is finally learner? As a machine learning engineer, if you are a trainer, who is learner? You are a trainer, there should be some learner. That means student. That is model. Understand? The model is a mathematical instrument for doing the predictions. So what type of models will be here? Basically three types. What are those? Yesterday we discussed. Predictive models, clustering models, yeah, recommendation models. Write some brief about it. Scikit-learn, still extension. What is the style of scikit-learn? We will see. The predictive models generally, you have regression models. Classification models. So online team, please prepare notes, sir. Suppose if it is regression, we have linear regression, polynomial regression, lasso, ridge, decision tree regression, random forest regression, support vector regressor. So such kind of models are predefinedly available for you. These regression models are used to predict target continuous value. What do you mean by continuous values? Value can be anything. Suppose I am asking your age. Just by seeing your face, my model has to predict your age. If I ask a first person age can be 20, next person is 30, next person age can be 40. The value can be anything. If such kind of values are called continuous values here. To predict a target continuous value, the regression model. Okay. So you have different models based on the data patterns, situations. We need to use different models. Okay. So for all these things, programmatically implementing all these things is really lengthy process. This library will make it simple. Similarly, classification models, sir. Suppose I am asking your gender. First person gender male, second person gender can be female. If I collect data from 1000 people or 10,000 people, answer can be either male or female. That is what a classification. That means target value is a classifier. Even in Gmail point of view, if I send a mail, mail can be spam or personalized or social media or promotion. Even out of 1000 mail, every mail belongs to any one of these four categories. So such kind of values are called classification. To predict a target classification, suppose tomorrow it will rain or not, tomorrow share value up or down, such kind of questions are in my mind. For all these things, the classification models have to be used. So for this classification, again, the scikit-learn is giving you a lot of libraries, a lot of classes. So these models here in the classifications, logistic regression, decision tree classifier. That means decision tree is available for regression, decision tree is available for classification. Random forest classifier. Naive Bayes classifier. Support vector classifier. Support vector classifier. But this sklearn is not good for the deep learning, sir. It's good for only machine learning. When time comes for deep learning, you have to use other libraries. Understand? In the case of this is about predictions. And in the case of what is the next category of models, sir? predictive models. Second category is what? Clustering models. Under clustering models, you have k-means. K-means plus plus. K-median. Such kind of models will be there. And when I talk about recommendation models, there are three categories: pattern-based recommendations. For this, please come. A priori, FP growth. Such models will be used. Graph-based algorithms. Graph-based recommendations. Here, different graph algorithms will be used. Actually, graph data means what, sir? Connections between records. Suppose, how is the Facebook user and friend connections? Hello, master, please. In Facebook connections, what will happen? I am adding you as a friend. Now you are my friend. You have some other friend. Again, he is adding the other different friend. The fourth one or fifth one, again, he is adding. This entire thing is what? A graph. So whenever you entered into Facebook, whenever you sign in into Facebook, you may know this person is one of the recommendation. Suppose already you are my friend, no need to recommend you to me because you are already my friend. But my friend of friends are recommendation to me. Understand the point, sir? I have 10 friends, but these are direct level friends, direct to first level friends. For my first level friends, there are second level friends. That means my friend of friends, which are not known to me, those are recommendation to me as a you may like this, you may know this person. But you may like is different, sir. You may like means what? I'm a person who is keeping interacting with the data science related postings and article readings like that. And other by a person behavior is also same. There is a huge similarity between me and him. Understand? Whatever he is liking, that I may like it. Whatever I like him, I like the article. He also may like it. Between users, if there is a similarity in the behavior, if one user likes it, another user will also, most probably he may also like it. On such way, you may like this person, you may like this article, such kind of recommendations. That concept is different. So here we are talking about especially Facebook and LinkedIn point of view. You may know this person. Whenever you sign in, automatically some connections are recommended to you to add a new connection. So such kind of recommendations are graph-based recommendations. And there is another thing, user similarity based. Whatever you may like, not you may know, you may like this person. That is similarity based. Okay. For doing that, similarity based recommendations. Here different algorithms like collaborative filtering. Under collaborative filtering, the sub things UBCF, user based collaborative filtering. IBCF, item based collaborative filtering. Okay. And there are some special algorithms also there for this purpose. ALS, alternating least squares method. Mathematically very complex computations, but here no need to worry. Library will take care of them. What is our library to implement all these things? sklearn. That means scikit-learn. The shortcut form for the scikit-learn is sklearn. Okay. All above models are predefinedly available in scikit-learn. Only as a machine learning engineer, you should have clarity when to use what type of model. If I am sure in this moment I should use decision tree is ready. At the time of building recommendation systems, I decided to use alternative least squares method. That class is also available. In just 3 to 4 lines of statements, you can implement that. Understanding this point, sir. Next one, scikit image, the next package module is advanced and simplified. Image preprocessing. Library when compared with SciPy. Advanced and simplified. Previously, before the scikit image, SciPy will be used for the same purpose. But if it is SciPy, little lengthy process. When compared with the SciPy, more simplified and more advanced features are added into scikit image. But it won't suitable for audio and remaining things. It's useful only for image and video only. Okay, image and video both you can do. The next, NLTK. Okay, before that, going for NLTK, let's go with Theano. Used for deep learning. Actually, this deep learning is advancement to neural networks. But it was hero before TensorFlow came into the picture. Google has released one library, TensorFlow. So daily used to hear news about driverless cars, which is made by the Google. The Google's driverless car computational graphs are designed by using TensorFlow. Understand the point? That is what the trend, that is what we are going to work more, especially the deep learning related. Got it? TensorFlow. Used for both machine learning and deep learning. Computational graphs. You can say advanced to Theano. Both Theano and TensorFlow supports CPU and GPU computing. Generally, our regular programs and our data will be processed at CPU level. But if you talk about animation applications or biggest gaming applications, that means multimedia applications, they will be using GPU computing. This GPU computing is 100 times faster than CPU computing. Even in my practical trainings also, especially for image detection point of view, image recognition point of view. In deep learning, I trained my model with 12,000 images, sir, with regular CPU computing. Before going for sleep, I executed it. By morning 8:30, program execution was finished. That to deep neural network algorithms. That to convolutional neural network algorithms. Basically, here algorithm complex. 12,000 images means not a small deal. Okay, just to compute only 12,000. I'm not talking about lakhs of images. Only 12,000 images. The training is done by 12,000 images to my deep neural networks. Okay, the time has taken more than 10 hours. Same thing the next day, I executed with GPU computing. Okay, time taken is only 20 minutes. That would be with 1 GB GPU. Understand the point, sir? 1 GB GPU. But industry uses like very powerful GPU cards. That to 6 or 7 GPU cards they will be using. Especially such kind of model buildings. At the time, even though that much of volume, that much of complex algorithm is running, the time taken is in minutes only. Understand the point, sir? That to do this TensorFlow is very effective for creating computational graphs, flows. Suppose data extraction is first step, immediately data cleansing, immediately data preparation, immediately model training, immediately accuracy testing. It's all what a computational graph. Understand the point, sir? For designing such kind of workflows, the TensorFlow is very flexible when compared with Theano. So before TensorFlow came into picture, Theano was popular for neural networks and deep neural networks. Now TensorFlow. So most of machine learning engineer applicants will apply like sklearn, scikit-learn. All these are outdated. Just as a beginner, just to know what is a machine learning, scikit-learn will be useful. Now entire industry in their production applications they are using TensorFlow. So if you have TensorFlow in your resume, a great weightage for you. Understand the point, sir? Machine learning, okay, you know all machine learning models, but to implement them, there should be some weapon, right? The weapon is TensorFlow. Got it? Yeah. The next one is Keras. Is library for deep learning again. Keras runs on top of TensorFlow or Theano. That means Keras cannot independently run. Keras will run on top of TensorFlow or Theano. At the time of installing Keras only, you have to choose whether you want TensorFlow or Theano. Got the point, sir? Default is with TensorFlow. But already your implementations are in Theano. At the time of installing Keras, you have to choose Theano. So what is the advantage if I go with TensorFlow? Especially implementation of neural networks. The two simple neural networks is very lengthy code. Suppose 100 lines. TensorFlow made it as 10 lines. Keras is making it as 2 lines. The two deep convolutional neural networks I want to implement by using traditional programming. Maybe that will be a 1 month time taking process to develop such kind of things. In TensorFlow, I can design it with 50 lines of code. If I come to the Keras, the same thing I can implement with 5 lines, 5-line piece of code. Understand the point, sir? That much of simplified process. Getting this? But a tensor that Keras cannot independently run. It should use either TensorFlow or, but you are writing in Keras, during execution that will be converted into TensorFlow. That is what the meaning of last statement. Keras runs on top of TensorFlow and Thean, right? Yeah. So very simplified than this previous processes. A complex deep neural network also you can easily implement it. Next, Cafe. This is same as Keras. Cafe. Same as Keras. But capacity wise, both are okay, sir. Whatever Keras can do, Cafe can do. But industry is using Keras mostly. That's why we learn Keras. Understand the point, sir? Very rare clients will be using Cafe. But power point of view, both have same power. You cannot say Keras is great. Yeah, same. Cafe will also run on top of TensorFlow or Thean. Especially these are the high level libraries. That's it. This is your book, that is her book. Understand? Somebody will purchase your book, somebody will purchase their book. Like this, most of clients are using Keras for deep learning applications. Let's follow that. Okay. Nowadays, sir, TensorFlow 1.2 onwards, you need not to install even Keras also. If you install TensorFlow, automatically TensorFlow is coming with Keras graphs. TensorFlow 1.2 onwards. Before 1.2, what you have to do? First, you have to install TensorFlow. Later, you have to install Keras. Now, 1.2 onwards, just install TensorFlow. That is available with you. No need to work with specified, specially install and downloading this one. Understand the point? Next library. OpenAI Gym. OpenAI Gym. You can guess what is the meaning of it. There is a statement called AI, artificial intelligence. Okay. Used for creating simulated environments and train agents in artificial intelligence. You want to develop a self-car driving, sir? Directly on the roads, can you develop algorithm and can you release that onto the roads? You cannot. You need some simulation environment. Okay. The environmental related all libraries are available. You want to develop a environment for, you want to train our smart cab. Suppose think that there is an environment. Customer location is that X place. Destination is at some Z place. Okay. When customer has called from source location. At the time, cab may be at location U. Location U2, it has to go to the source location. By following the traffic rules, it has to reach the target destination. That too in a optimized way, it has to go. By following the rules, at the same time, it has to follow the rules. At the same time, in optimized way, it has to go to that place. On such way, you want to train our cab without driver. But to train our agent, here cab means your agent. In machine learning, we train models, sir. In artificial intelligence, we train agent. Understand? But agent has to learn it, right? To learn, it needs environment, right? These environments are predefinedly available. Think that this environment is based on the US traffic rule. We want to implement it for Hyderabad, that too, especially for Amirpet. Understand? You need customizations or not? First, take existed environment to do customization and leave your agent to travel it. Understand? Especially in artificial intelligence, training the agent is not a big deal, sir. Algorithm will take care of it. But creating that simulated environments is very tough deal, sir. Understand? To create such kind of simulations, Open AI Gym will be used. Getting the point? Yeah. So this is the reason why Python is great. Whatever the task, whatever the purpose you select, the purpose related library is available. More than 8,000 libraries are there into Python. Of course, don't start learning of each and every library. Your age is not enough for that. Understand? How much is required? What are all the libraries related for our data science or machine learning, deep learning? Concentrate on them. Right. Next, NLTK, Natural Language Toolkit. Natural Language Toolkit. It's used for NLP. NLP full form, Natural Language Processing. Okay. Mainly here two activities will be there, sir. Number one, pre-processing. Pre-processing of the text. That means unstructured typed text. A customer is giving review about you, about your organization or about your product, something. I'm a customer. I type my review in my own style. You type your review in your own style. There is no fixed pattern for that. Understand the point, sir? Suppose review number one, sir. I like it. Some other review is like this, sir. Meaning what, sir? Is it a structure? Is he following the rule? Understanding my points? Okay. Especially in the chat language, you can observe such kind of patterns. Okay. A lot of sounds we are doing. Especially you and me are chatting, or you and your friend are chatting. We don't follow any rules. WHRU. HRU. What is that? Understand the point, sir? Okay. WRU. What is that? Such kind of things we used to use. A very informal words we will be using into that one. Okay. So mainly this NLP has two responsibilities. One is pre-processing of the text. Second one is numerical feature extraction. If I talk about pre-processing of the text, generally, sir, a customer review or an article definitely will not contain one sentence. It contains multiple of sentences. Whenever I have given you some paragraph or a page, can you read at a shot entire page? You cannot. First, you have to split them into sentences. Or at least the sentence is bigger. Can you read the sentence at a time by a single look? You cannot. Word by word, you need to come. So first, like here, pre-processing activities like sentence tokenization first. Then word tokenization. Actually, here word tokenization means word punctuation tokenization is important. Okay, word punctuation tokenization. Because programmatically handling the punctuations is very tough. That's why we take help of libraries. Next, lemmatization, semmatization, removing stop words, word clouds building. Such kind of activities are called pre-processing of the test activities before you train our models. Okay. And also one more activity I forget. POS tagging. That means parts of speech. How a word is playing, what kind of parts of speech it is playing, based on that meaning will be changing, sir. Suppose a small example. Observe this. I said I love you. What is the role of the word love here? Verb or noun? In this example, in this sentence, what is the role of love? Verb. Love is God. Now, playing as noun, right? English word same, but in different places, different roles it is playing. Based on its role, the meaning will be changing. Are you getting my point? Please come, sir. Okay. So, the word role you need to identify. Based on that, the sentence meaning, sentiment, everything will be changed. So, POS tagging is one of the important area. So, identification of such kind of things. Programmatically, point number one: what are all your challenges? Point number one: we don't know English. Okay. According to our English, we know very few words only. We don't know all the things. That is challenge number one. Challenge number two: really making them identification of each and every word and recognizing their parts of speech based on the place in the sentence is not a small task. A simply one POS tag, one simple function will take care of all these things. Understand, sir? On that way, library is helping you a lot. I don't use library. I will write hard coding means industry don't want you. First of all, you have to learn how to program it, and after that, how to use it, how to make it faster. The same work by using library, because industry needs these things. Okay, without using the library, I will develop the same thing with 30 days means they don't want you. Use the library within 1 hour, finish that work. They need you. Understand the points. Next, numerical feature extraction is one of the second important area in the NLP. Why we need to extract numerical features from the given text? Sir, first listen me, attend me please. Later, whenever I type, you just note it down. What is the need of extracting numerical features? Finally, machine learning purpose what, sir? We are going to train models. Deep learning, say. Of course, one is simple patterns, another one is complex patterns. But whatever it may be, in machine learning or deep learning, you are going to train your mathematical models only. The mathematical models are expecting numerical data, not text data. If features are 10 and 20, 10 into 20 is 200, you can say. If features are I and love, I into love what, sir? Or love into you what, sir? Nothing. It cannot compute it. Because every model is based on linear algebra. Then it's numerical features. But my customer review is not a number, is a text, is a raw text. Your chat messages is a raw text. Understand? I will have to convert numerical features. There are a lot of numerical feature techniques are there, like word existence feature, word proportion, lexical diversification, TF IDF, term frequency, inverse document frequency feature, t-SNE. In this way, different features are available. But which feature is good means based on the situation. You cannot say that model is good, this model is bad. In one situation, model number one is good. In another situation, model number two is good. Like this depends on the data pattern and situation. Different feature extraction techniques are there. Okay, in a right time, right technique we need to use. Otherwise, your training of the model will be failing. Understand the point, sir? But a numerical feature extraction from the raw text is really tough. Here you have libraries because the mathematical computations are very complex. Okay, the library, one single function will take care of it. What kind of feature you want, you have to choose that feature. Got it? So first of all, be clear why you need to extract numerical features. Because your models are expecting numerical data. Based on this, you tell me, NLP can do two things. Pre-processing. Second thing, feature extraction. But what it cannot do, it cannot train our models. Again, to train models, I need to use machine learning or deep learning or not. Okay? Yeah. Instead of by feeding raw text to train the model, first I will pre-process the text, I will extract numerical features, and then I will push that into models. Then models will learn the patterns. Once models have learned, if any new customer review comes, whether it is a positive review or negative review, the model will say. Same Gmail spam engine point of view, tell me, sir, guide me about this. Mail 1 label spam, mail 2 non-spam, mail 3 spam. In this way, some 10,000 emails I have collected. Let's say spam means 1, non-spam means 0, because it needs a number about the label. But what about the feature? Feature is a raw text, right? Your email body is a raw text, right? That raw text should be undergone through pre-processing, and then numerical features have to be extracted. Then train our model. The model can be our machine learning SVM model or deep neural network models. It can be anything. Understanding this point, sir? Yeah. Right down. Why to extract numerical features? The ML models or DL models are expecting numeric data as features and labels. ML models or DL models are expecting numeric data as features and labels. Label means target values. Whether it is a positive sentiment or negative sentiment, that is what a label. Whether it is a spam mail or non-spam mail, that is a label. Your type text is a feature, but feature is in text format. Convert into numerics. Before converting into numerics, pre-processing. Understand? Now with the NLP with machine learning is very, very great demanded, sir. What are all the regular applications what you see? Spam, WhatsApp, ఇంకా ఇక అన్ని సోషల్ మీడియాలో పేర్లు చెప్పుకుంటే 1000 వస్తాయి. అవి కాదు, అయిపోయింది. Chatbot is not machine learning and NLP. AI and NLP. That is recommendation model. That is a recommendation model. Text classification, whether it is a spam or non-spam, whether it is a positive sentiment or negative sentiment. Text. Hmm? No, 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 no. Hmm? Sir, Telegram is a like a WhatsApp kind of application. Within that, where is the role of ML and NLP? I am asking. తెలిసిన అప్లికేషన్స్ అనే చెప్పొద్దు. సింపుల్ సార్, కస్టమర్ రివ్యూ ఐడెంటిఫికేషన్, సెంటిమెంట్ అనాలిసిస్, ఒపీనియన్ పోలింగ్, okay, opinion mining simply, text classification. These are the top 10 stories today in our news sites. Hmm. Hmm. All these are what? NLP and machine learning combination based applications. Deep learning and this one, sir. Deep learning and NLP. Yesterday I told you one example. In Google, whenever you type something, after typing 3 words, it is predicting fourth and fifth words. Feature words it is predicting. As simple, sir. Here, what is the challenge is, just observe. Sachin. Madam, sir, please. Here. Sachin is a great. Next what, sir? Great. Next what, sir? Cricketer or batsman. Automatical application has to predict it. Understand the point, sir? Suppose I said like Ganguly is a great captain. Automatically our application has to say that. How you could able to say, sir, he's a great cricketer? Just by seeing the statement, you did not say. Before that, lot of journey was there. Based on that journey, you could able to predict the next coming what. Understanding my point, sir? So this is what like the feature prediction of the series of feature words. Okay, but not only the words, sir. This question, this should be the answer. Hey, how are you? What is expected answer, sir? Huh? What is expected answer? Automatically, yes, I am fine. Okay, immediately one more question also. After answer, one more question he will rise. How about you? Like this. Okay, such kind of things. In that case, predicting the future words or future questions or future answers, that will be done by deep learning with NLP combination. Understood? Especially in the deep learning for this problem solving, recurrent neural networks will be there. Image object detection, convolutional neural networks will be there. And for this, recurrent neural networks. That too, within the recurrent neural networks, LSTM technique, long-term and short-term memory. Long short-term memory. That means you have journey from, suppose your age is 25 or 30. You have journey of 29 years. Something you kept in brain, something you forget it. What to keep into brain, what not to keep into brain, you have clarity. That's the reason whenever I ask you 2 into 3, you could able to say answer. Whenever I ask you 22 into 43, you cannot say answer. Understand the point, sir? Long and short term memory techniques will be used to do such kind of activities. Nowadays, that is using not only in NLP, lot many other cases. What will happen to my share price in the next moment? I want to estimate it. At the time also, this recurrent neural networks will be useful. Very effectively, these will be doing. Understand the point, sir? Okay. Yeah. So here, ML and NLP. Examples, sentiment analysis. Gmail spam detection, etc. Deep learning and NLP combination. Predicting future series of words. Don't say future, next series of words. Words are sentences. For this ML and NLP libraries, please. What you can use? For machine learning purpose, scikit-learn plus NLP. Nowadays, scikit-learn slowly kept into storeroom. That means outdated. You can use TensorFlow. Got it? In this way, your work is not with a particular single library, sir. Your work will be with a combination of libraries. Again, when I come to the TensorFlow, again I need data preparation, right? A lot of data cleansing activities I need to do before I start working. Again, pandas. I need to implement a lot of linear algebra, NumPy. Understand the point, sir? In this one. Here, what you can use directly. Here, NLP, nice, sir. Library. What is the library for NLP? NLTK. NLTK. NLTK is a Python library for NLP. DL and NLP, what libraries you will use? For deep learning, can I use Keras? For deep learning, can I use Keras? For NLP? Array by NLTK. Okay, sir. So what is the limitation of this NLP? Limitation. Can do only pre-processing, numeric feature extraction. But it cannot train the models, right? That's why you're again taking help of ML libraries and deep learning libraries. Next, text blob. BLOB, sir. Combination of NLP and ML. Understand the point, sir? Previously, NLP library, NLTK. NLTK, what it can do? Pre-processing, numeric feature extraction. Again, to train, ML library, scikit-learn or some other TensorFlow help you how to take it, right? No need to go. Go with a text blob. Itself can do pre-processing. Itself can do numeric feature extraction. Itself can train the model. Understand the point, sir? It's a combination of NLP and ML. In this way, one advanced version came into picture means your work got reduced, sir. More simplification with some extra feature, that your work will be reduced. Got it? Same next, RASA. Same as text blob. BLOB. RASA. API.ai. API.ai. It's AI plus NLP. Used for chatbots. Nowadays, there is a great demand for chatbots. That too, not script-based chatbots, AI-based chatbots. What is the difference? AI-based and script-based. Fixed in the sense. Fixed means this is the question, this should be the answer. What is the course fee? 25,000 is the course fee. Sir, I am under struggle. Can I pay installment? Can you give me some other discount? Okay, such kind of things it cannot answer. Understand the point, sir? But if a human is really chatting, he will answer it that right based on the opponent person question. By understanding him, he will be answering accordingly. Like this, our artificial intelligence chatbot will behave. To develop such kind of AI-based chatbots, the library is API.ai. Nowadays outdated. Okay. Yeah. Now the second thing is Google Dialog Flow. This is super. Google dialog flow. Dialog flow, keep it as single words. Use capital F here. Now API.ai is renamed as dialog flow. So previously some third party, after that Google has acquired it, added a lot of features into that one, and make it more simplified with the TensorFlow features, and they renamed it as dialog flow. Got it? Yeah. So all these are the different libraries. Got it, sir? We'll be using into this one. Machine learning, deep learning, NLP in different cases. So once again, you tell me ML and NLP combination. ML and NLP combination. Sentiment analysis. Spams. Okay. Or else like not only spam and non-spam. Any classification of the text. Suppose for my training center is X. For all the customers, info@x.com I am giving. A Java seeker will be mailing to that one. Data science seeker is mailing to that one. Data analyst seeker also is mailing into that one. Based on the mail, automatically emails have to be classified. My model has to understand, okay, this is an email regarding data science. This is an email regarding Java. This is an email regarding some Python, like that. Understand the point, sir? Based on the mail, whether it is an inquiry or a complaint, my model has to understand. All these work are called text classifications. In so many cases, you can use that. Understand? And deep learning, series words. If I type some sentence, based on the sentence pattern, what would be the next word or next sentence it has to predict. Such kind of things are deep neural networks are deep learning and NLP combination. AI and NLP means you have seen now. To develop AI based chatbots. Understand the points? Suppose RPA is there. Nowadays the word RPA. RPA is also having the facility called chatbots, but those are script based chatbots. But this is the Dialogflow is the library for AI based chatbots. Understand? In this way, in data science, your Google is going to play a lot of role. Google will help you, sir, by providing you the document when you search it. Already we are taking the Google help for that. And second way, providing powerful libraries for you. Got it? Yeah. Okay, sir. Tomorrow, actual Python programming we will start. It's all like yesterday, today class. Okay, we discussed about in our data the Python for data science. What kind of libraries, what each library purpose like. Tomorrow, actual programming of Python we will start. Right?